So as promised everyone, we are back for example 1 continued. We just found the 3 options for this company in terms of the plants that they have available. And for option example 1 continued, we have a twist in this problem. Each hour of operation at the Atlanta plant has associated costs of $700. So every hour that this plant runs, it costs $700. While each hour of operation at the Fort Worth plant has associated costs of $2,100, which is way more. It's 3 times as much. And if you are looking here, it's interesting because the Fort Worth plant is capable of producing the exact same number of cappuccino machines per hour, but they are able to produce about 5 times as much of the 12 cup machines per hour. And so this is a quandary that this company has to figure out. Gee, do I go the cheaper route and use Atlanta, or do I go the more expensive route with Fort Worth and produce 12 cup models faster and produce cappuccino machines at the same rate that I would Atlanta? It's very complicated to try and figure that out without doing what we have just done. So this makes figuring that question out of what is the cheapest option very simple. So what we need to do, everyone, is set up a cost function for this problem. And so for Atlanta, cost is $700 every hour. And so remember, Atlanta is we assigned X to Atlanta, so 700X. And at Fort Worth, costs are $2,100 every hour. And we assigned Fort Worth the variable Y. So our cost function is going to be these two plants added together. So for every hour that I run the Atlanta plant, it's going to cost $700, and for every hour that I run the Fort Worth plant, it's going to cost $2,100. What we're going to do now, folks, is use the information that we got from GeoGebra and plug that information into this equation to see which option is best. So option A, I'm going to replace X with 0 and Y with 200. So I would have 700 times 0 plus 2,100 times 200. For option B, we would have 700 times 150, 150 hours at the Atlanta plant, plus 2,100 times 50 hours at the Fort Worth plant. And then for option C, we will have 700 times 400 hours at the Atlanta plant, plus 0 hours at the Fort Worth plant. So as you can see, everyone, option A has the Atlanta plant shut down, and option C has the Fort Worth plant shut down, while option B is a blending of the two. Now, many people think automatically, I should just run both plants because the job will get done quicker. The answer to that is no. We've already figured that into our considerations. And so this is providing a perfect solution to this problem that will keep our costs as low as possible while still getting the job done in the time frame that we need to get the job done. So do not make assumptions that this middle option is going to be the best one, because as you're going to see in a moment, that would cost you a huge amount of money. So let's take a look, everyone. We are going to test option A, 700 times 0 plus 2,100 times 200. And we see that option A would have a total cost of $420,000. That's a lot. That might be the cheapest option, but we are going to find out. And so option B is 700 times 150, and then only 50 hours at the Fort Worth plant. So $210,000. So we are noticing that the middle option right now is currently the best option, coming in at a cost of $210,000 less than option A for doing the exact same job in the exact same amount of time. That's a big deal. Saving $210,000 to, again, do the exact same job in the exact same amount of time. Let's test option C and see what we get. So option C is going strictly with the Atlanta plant and shutting down the Fort Worth plant completely. Option C has an associated cost of $280,000. So still cheaper than option A. But as you can see, it did end up working out correctly that option B was going to be the correct option with associated costs of $210,000. Recognize, though, that this is not an even split. We are not spending 100 hours at the Atlanta plant and 100 hours at the Fort Worth plant. We are doing 100 hours, 150 at Atlanta, and 50 at Fort Worth. If you were to do 100 hours at each plant and split it evenly, you would not be landing on a corner. And it's not it is a solution to this system, but it's not one that's going to be effective. If we split it evenly, we're back up to $280,000, again, costing us $70,000 more than this option. And so you can see that if a person was just to say, hey, I'm going to split the work evenly between the two plants, it's going to cost this business $70,000 more than it would if they put 150 hours into the Atlanta plant and 50 hours into the Fort Worth plant. So my response to this business would be work the Atlanta plant for 150 hours and work the Fort Worth plant for 50 hours. With that, everyone, that is a completed problem. These problems are sort of beasts, but as you can hopefully tell from the result that we are getting down here in terms of saving at least $70,000 by doing what we recommended, and at most $210,000 by doing what we recommended, that this has a ton of value in business and in terms of figuring out how you can operate, get the exact same job done, and either keep the costs as low as possible while doing it, or maximize your profit.